Hi everyone. Today we will discuss variance and standard deviation. Variance is a very famous statistic that is a measure of dispersion, or how far a set of numbers is spread out from their average mean. Okay? And variance is defined by you must find the deviation, which means individual value minus mean, then squared, then add them all and divide by n. Okay, that is the variance. We have another definition here, very similar one, except the denominator. On your left expression, you divide by n, and on your right equation, you divide by n minus 1. That is the only difference. The left equation can be used for population, and the right equation is used for sample. Please note that the main purpose of a sample is to guess about the population. In the case, we must divide by n minus 1. Okay? And one more thing, standard deviation. If you can find the variance, standard deviation is just the square root of variance. Easy to calculate. Okay? Okay, here's two examples. 3, 4, 5, 6, 7 is the first data set, and another data set is a 1, 3, 5, 7, 9. I assume this is the population, so I will use the left side formula. So I will use the V is a variance. Squared divided by n, right? I will use this method to find the variance first. I will make a table. This is the xi. 3, 4, 5, 6, 7. Now, next column, xi minus m, or mu. Mu is the mean of the this data set, and from this, what is the mean? I think mean is the 5. Add them all and divide by 5 is 5. So what is the x minus mu? We call this one is deviation. So here 3 minus 5, 4 minus 5, 5 minus 5, 6 minus 5, 7 minus 5. Okay. Now last column is xi minus mu squared. So the squared value of our previous column. So this is the 4, 1, 0, 1, 4. Okay. Now what is the sum? Sum is 10, right? So variance, I will just use a V. Sum divided by how many numbers are there? 5. So 2 is the variance. Question asks us the standard deviation, right? So standard deviation will be square root of 2, about 1.414. Okay, this is the standard deviation of the data set 3, 4, 5, 6, 7. Okay, let me repeat this whole process for another data set 1, 3, 5, 7, 9. xi 1, 3, 5, 7, 9. Interestingly, mu or mean is the same as our previous example 5. If you add them all divided by 5, this will be 5. Now it's time to find x minus mu. 1 minus 5, 3 minus 5, 5 minus 5, 7 minus 5, 9 minus 5. Now xi minus mu squared. So 16, 4, 0, 4, 16. I think this is the 40, right? Sum is the 40. Okay, so what is the variance? 40 divided by 5, which is 8. Okay, now what is the standard deviation? Is the square root of 8. Since the square root of 8 is 2, square root of 2, this is about 2.828. The reason I gave this example is to compare the dispersion. The standard deviation 1.414 is the situation of this one. And standard deviation 2.828 is the situation of this one. Can you see the difference of their dispersion? This is a narrow dispersed data set, and this is a widely dispersed data set. Okay? So that value by number we can guess when your standard deviation is 1.4 something. Okay, this is a narrow dispersed. When your standard deviation is 2.8, by comparison of these two numbers, we may have a much wider dispersed. Okay? Okay, let me briefly summarize one more time. Variance defined sigma xi minus mu squared over n. This is a for population. And we have another definition for variance. Sigma xi minus m. In this case, m and mu has the same mean, but usually mu is used for population and m is used for the sample. Okay, that's why I use the m here. Another definition is divided by n minus 1, and this equation is used for sample. Okay, and if I use another notation for variance, for the sample, we use S squared. For the population, small sigma squared. Okay. So if you use just sigma, then is it okay to say that this is the population standard deviation? Is yes, sigma squared. Numerically, this is quite straightforward, right? And in statistics, after you find the variance, in this case, for the sample, we use S for standard deviation, is here. Okay? So this is the standard deviation. Good? Okay, thank you for watching. See you next time. Bye-bye.